All right, so food and clothing are being sent by commercial airplanes to hurricane victims in Florida. Each container of food is estimated to feed 12 people. Each container of clothing is intended to help 5 people. The organizers of the relief effort want to determine the number of containers of food and clothing that should be sent in each plane shipment that will maximize the number of victims helped. If X represents the number of food containers and Y represents the number of containers of clothing, write an equation that expresses the number of victims that can be helped in terms of X and Y. So what would N equal? So X is food. How many people does a food container help? 12. So it would be 12X plus how many people does a clothing container help? 5. So plus 5Y. So in the end, we're going to plug in X's and Y's to this and figure out how many people we can actually help out. This is the equation that we just wrote is our objective function. In this problem, you want to determine the maximum number of people that can be helped. The objective function expresses the quantity to be maximized, or in other cases minimized, in terms of 2 or more variables. The commercial aircraft that are used to ship the containers have weight and volume restrictions. Such limitations are called constraints. Each constraint is translated into a linear inequality. All of the constraints form a system of linear inequalities. When graphed, the solution of the systems of inequalities are called the feasible region. What does feasible mean? What does it mean if something's feasible? Is it feasible you could get an A in this class? Yes, it is, because it's possible. So this is the possible region. It means where all the possibilities that could work occur. So let's write our equations. The weight and space restrictions imposed by the airlines are summarized as follows. The total weight of supplies cannot exceed 19,000 pounds, and the total volume must be no more than 8,000 cubic feet. Each container of food weighs 50 pounds and occupies 20 cubic feet of space, and each container of clothing weighs 20 pounds and has a volume of 10 cubic feet. So, weight constraint. What are we worried about for the weight? It can't be over what? 19,000. So do we want our containers to be less than or greater than? Less than or equal to. How much does a food container weigh? 50 pounds, so 50x. Plus, how much does a clothing container? So 20y. Using that idea, I want you guys to try and write this one for the space. It's extremely similar. So what's our restriction for the space? No, what's the restriction? Can't we go over? Can't go over 8,000. How much does a food container weigh? Plus, how much is the clothing? 10y. Or it doesn't know how much it weighs, how much space it takes up. All right. Additional restrictions on the number X of food containers and the number Y of containers of clothing is written as X has to be greater than or equal to 0 and Y has to be greater than or equal to 0. Why? Why do we have these restrictions? We talked about it a little bit when we did the restaurant problem. We were figuring out how many people were going to order beef and how many are going to order chicken. Right, we can't have a negative number of containers. You may want to put a star by this one because when you go to do your project, this is the most common thing that gets left out. Is the x is greater than 0 and y is greater than 0. All right, we're going to have to graph these, but before we can do that and label our graph, we're going to have to figure out the x and y intercepts for both of these equations that we already wrote. So how do we find the x and y intercepts? Okay. The cover up and then divide. So 50x equals 19,000 and 20y equals 19,000. What's that going to make our x-intercept and our y-intercept? So what's our x-intercept? And our y-intercept? And same idea for the space restriction. 20x equals 8,000 and 10y equals 8,000. Go ahead and find the x-intercepts and the y-intercepts. So what's our x-intercept and our y-intercept? 800. All right, so let's look at our graph. What does our x-axis represent? Containers of food. And what does our y-axis represent? Containers of clothing. All right, so how many boxes do we have on the food axis? And what do you think we want to count by based on our x-intercepts? Based on our x-intercepts?
Well, I looked at them both. I looked at the highest number from all four.
We just want to look at the x's. Because if we count by 50s, is 380 going to be an exact spot? What do you think we should count by? I would count by 20s. So the first box is 20, or if I want to go 5 boxes, how much would it be worth? What? 100. Just makes it easier with the labeling.
So it's the same as like 20, 40.
Right, I'm just only labeling every 5th one. Mostly because it's a pain in the butt to label all 20, or yeah, all 20 spaces. All right, vertically, the clothing side, I would count by 50s because that would put it up to 1,000. So 100's only 2 boxes this time. do we need to work, when we graph all these constraints, which technically we have 4 of them. We have the weight constraint, the space constraint, and then we have the 2 for x has to be greater than 0 and y has to be greater than 0. Are we actually going to have to graph these 2? No, because we didn't draw any negative space on our graph, so technically those are already graphed for us. So connect an x-intercept of 380 to a y-intercept of 950. So 380 to 950. The main reason it's important to make sure you guys are using a ruler or the side of your calculators is because the points where they intersect are going to be really important. So we need to have straight lines so we can make sure we get the exact intersection points. You're connecting x on the 3, so you go to where x is 380 and connect it to where y is 950. And then for our second line, we'll connect where x is 400 to where y is 800. So our feasible region is anything above 0 for x and for y, or below the red line and the blue line. So it becomes all this space under the red, then once they intersect, it's under the blue, and everything down here. So all this area, that's our feasible region. Those are the various amounts of containers we can ship. Now, we want to know the maximum number of people we can help. And the way we're going to find that is by looking at the corner points of what is my pink section. So 0, 0 is one corner. 0, 800 is another corner. 380, 0 is another corner. Where's the fourth corner? Where they do what? Where they intersect. So in this case, it would be, it's a little hard to tell, but it's 300, 200. So on your chart, in the next part, we're going to label the corner points. So 0, 0, 0, 800, 380, 0, or 300, 200. The next thing we have to do is remember that equation we wrote at the very beginning that would tell us how many people we can help? So here's your x, here's your y, plug it in. So 12 times 0 plus 5 times 0. Or 12 times 0 plus 5 times 800. 12 times 380 plus 5 times 0. And 12 times 300 plus 5 times 200. So now you're going to type all these into your calculators, and that's going to tell you how many people we can help in each situation. So ready, set, plug in. All right, so if we send 0 food and 0 clothing, how many people do we help? 0. If we send no food but 800 things of clothing, we help 4,000 people. If we send 380 of food but no clothes, how many people do we help? 4,000 what? 560. If we send 300 food and 200 clothes, how many people do we help? 4,600 and... I'm asking you guys. 4,600 people, yeah. Just type it straight like that in your calculator. All right, so what is the maximum number of hurricane victims that can be helped per shipment? 4,600 if we do what? If we send... Right, if we send 300 food containers and 200 clothing containers. So basically what we just did is what your project's going to be. Okay? So there are 6 steps to it. I'm going to... What's that? All right, so steps. First thing you got to do, define the variables. What does X represent? What does Y represent? And write the objective function. Which for us was our N equation where we figured out how many people we could help. Next, what did we write? What did we write next? What were these called? Starts with a C. Constraints. What does constraints mean? Restrictions. So we're going to write the constraints. Then what did we do with the constraints? Top of the page. Top of the page we're writing on. We graphed the constraints. Then from our graph, what was important? Then we found the corner points. Then what did we do with the corner points? Which equation? What was that called? Good. Plug the corners into the objective function. And then your last thing is to answer the overall question. Which for us in this one was how many people can we help?